I'm now going to do example 4.6. Suppose you play a game with a biased coin. You play each game by tossing the coin once. The probability of receiving a heads is 2/3, and the probability of a tails is 1/3. If you toss a head, you pay $6. If you toss tails, you win $10. If you play this game many times, will you come out ahead? All right, so we're going to start by defining our random variable x. So in this case, our variable x is the amount of money, amount of profit, or amount of winnings. So I'm going to call it amount of profit. So if our x comes out to be negative, that means that we're losing money instead of winning money. Next, we want to complete the expected value table. So we learned in the previous section, this first one's going to be x. The next column should be the probability of x. And then the expected value is going to be x times the probability of x. So we're going to end up multiplying here. So our first row talks about winnings. If we toss a tail, we win $10. So that's why this 10 is positive. The probability of a tail is 1/3. So there's the 1/3. Now the expected value, we would take 10 and multiply it by 1/3. This gives us 10/3. Next, lose. What happens when we lose? So if we lose, we are tossing a heads and we have to pay $6. So we're going to lose $6. The probability of this happening is 2/3. So here we're going to put the 2/3. To get this number over here, the expected value, we take -6 and we multiply it by 2/3. That gives us -12/3. Now let's answer the question where it asks us, if you play this game many times, will you come out ahead? So here's how we figure this out. Well, the expected value mu for the game in total is going to just be, we add these numbers in this column. So I'm going to add 10/3 plus a -12/3. If we add these up, they have the same denominator, so I can just do 10 minus 12, which gives me -2/3. Now, if I type this into my calculator, I get about -0.6667. Since we're talking about money, we're just going to round it to 2 decimal places because that's how we count money. So this would be 67 cents. So what does this -0.67 represent? This represents you lose, on average, 67 cents each time you play. So the question, do you come out ahead? No, because you're losing 67 cents every time you play. Now, if my number would have been positive, that would mean I would win 67 cents. So that would mean, yes, I'd come out ahead. I'd come out ahead 67 cents each time I play. But in this case, not going to happen because it's negative.